Okay, so today will be the last session on projectile motion, which is motion in 2 dimensions. We will be solving an exercise which is solved in your booklet. It is a solved problem in the booklet, page 19, number 1. It's solved. You just go there and find the detailed solution. I will just be solving it with you over here. It's very similar to number 9 on page 18, which we solved in a previous lecture. Okay. It's very similar to it. So make sure you understand problem 9, page 18. Make sure you can solve it on your own, page number 9, page 18. Then come to this problem, which is already solved, and try to do it on your own. Okay, so an emergency medical packet is thrown to a mountain climber from a rescue team at an angle of 60 degrees. Okay. What does it mean at an angle of 60 degrees? It means V initial was having an angle of 60 degrees. Okay, so this is V initial vector. This is V initial vector. It was thrown to a rescue team found on a mountain. Okay, so this is where it went to. So this is the initial position, and this is the final position. Angle 60 degrees. Now we know the theta. If the climber is found at a height of 270 meters, so what is this 270 meters? It is delta y. Okay, delta y equal to 270 meters, and a horizontal distance of 390 meters. So this is delta x equal 270 meters. Okay. This is delta x. Okay. Express the equation of motion x of t and y of t in terms of t and v initial. In all projectile motion exercises, the very first thing you do, even before it asks you to do anything, is you calculate v initial x and v initial y. Okay. And this you do it with the formulas that you've memorized already. I hope you have memorized them by now. V initial x is V initial cosine of angle theta, and V initial y is V initial sine of angle theta. Okay, theta is equal to 60. Theta equal to 60. So this is, sorry, this is 0.5. V initial, and this is 0.866, so let's say 0.9 V initial. Okay, so even if the question doesn't ask you to do this calculation, you always do it because you're gonna use it sooner or later. You're gonna use it. So let's start. Part A, express the equation of motion x of t and y of t in terms of the t and v0. Okay, so I will start x equal here, x and delta x will be the same. I will take the original position to be O 0, 0. Okay, I will take here O to be 0, 0. So delta x and delta y will be x of t and y of t. So let's start. X of t, or x, is equal. Here is the formula, V initial x delta t, but V initial x is 0.5 V initial. So this will be V 0.5 V initial times delta t. Let's say it's t, okay, to make it easier for us. Okay, this is x equal, and now what is y? Y equal V initial. This is part A to save space. Okay, y equal to V initial y delta t here, equation number 2. V initial y delta t minus 5 delta t squared. V initial y is 0.9 V initial. So this is 0.9 V initial t minus 5 t squared. Okay, so this is part A. Part B. Part B. Calculate the initial velocity V initial, just as we did with the basketball player, page 18, number 9. We will be using the fact that x is equal 390 and y is equal 270, that these 2 points are on the trajectory. Okay, So instead of x, I will put 390 is equal to 0.5 v initial times t, okay? And 270 is equal to 0.9 v initial t minus 5t squared. Okay, I want to calculate the initial. So I want to get rid of the t, because from here, I need to get rid of the t. If I can get rid of the t, I get my v initial. So to get rid of the t, in the first equation, I say t is equal 390 divided by 0.5 v initial. Okay. So I took 0.5 v initial to the other side. It becomes divided by t is equal to this. 390 divided by 0.5 in numbers using the calculator. 390 divided by 0.5 is 780. So I will put it in an easier way. So it is 780 divided by the initial. So this is t. Now I come to my second equation and I plug instead of t this 780 divided by the initial. So 270 is equal 0.9. The initial, I still have it. T, I will put 780 divided by the initial minus 5. T is 780 divided by the initial square. Okay. So from the first equation, we cannot do anything anymore. But the second equation, I can solve it further. 270 equal. Here I have 780. And here I have under it, there is 780. Sorry, here there is divided by. So this is t, right? Yeah, this is t divided 780 divided by vi. So there is vi by vi. They cancel each other. Okay, and I have 0.9 and I have 0.9 times 780. 0.9 times 980 is 702. Okay, so this is minus 780 square times 5. This gives me 304,2000 divided by vi square. Okay, so 0.9 times 780 is 702. 780 squared times 5 is 3,004,000 vi squared. Now let's continue solving this exercise. I get the 702 to the other side, so I have 270 minus 702 is equal to 304,2000 divided by vi square. This gives me 270 minus 702. It gives me minus 432 equal to minus 304,2000 divided by vi squared. The minus cancels the minus, and I do cross multiplication, so I get 432 is 432 vi squared equal to 304,2000. So vi square is equal to 304,2000 divided by 432. That's 7042. Okay, I do square root. Sorry. I do radical, so vi is radical 7042. This will be plus or minus 84 meters per second. It's plus or minus, but as you see here, it's going upward, so it's plus. This is how much is the initial velocity, part B. So this is part B. Part C, calculate the time taken by the packet to reach the climber. So he wants me to calculate the time. Okay, so time is equal to, from part B, the first equation, time is equal to 780 divided by the initial. This gives me 780 divided by 84, and this gives me 9.3 seconds. Okay, so I used this equation, T equals 780 divided by V. Okay, if you go back and check number 9, the way I solved it was by taking V initial T as the unknown and then plugging it, but it should give, if you do it the same way I did problem 9, page 18, you will get the same answers as well. Okay, what other questions he can ask me? So let's assume this is an exam problem. What other questions the examiner can ask me? He can also ask me, for example, find the maximum height. We can say find the maximum height. Okay, this is additional questions. Here is the maximum height. Here is the maximum height. Okay, so if he asks me find the maximum height, how do I solve it? Here I have to remember at maximum height, Vy is equal to 0, and you use equation number 5. Okay, so you come here, instead of Vy, you put 0. Okay, instead of this, you put 0. V initial Y, you already know it. It is 0.9 V initial. So it is V initial times, it is 0.9 times 84 minus 20 delta Y. So you get your delta Y. So if he asks you to find the maximum height, you use this equation and you plug 0 for the final Y. Okay, so that's it. I hope by now you understand properly all these projectile motion, all these different exercises. Tomorrow we will start with forces. So far we've been learning how the object moves. It moves with time, with velocity this, covering a distance equal to that, with an acceleration equal this much. Starting tomorrow, we will start asking the question, why? Why an object, why an apple, if I leave it, it goes downward? Why it doesn't fly upward? Why if I put a ball, why if I shoot a ball, it goes in a certain direction? Why it stops after some time? Why if I put a car on an inclined plane, it goes downward, it doesn't go upward? Okay. Why if the surface is slippery, it goes much faster and it covers more distance? So starting tomorrow, we will discuss forces and we will be dealing with the questions like why. Okay, for tomorrow's live session, I will be talking about projectile, in particular projectile that's making an angle where the V initial is making an angle theta with the horizontal. If you have any questions regarding any of the previous lectures in chapter 3, send me an email so as I answer them tomorrow in the live session. Okay, so till then, bye-bye.